propose you to build a very cool project, building your own agentic loop. You'll have an agent that is simpler, but similar to Manus and that runs in your own terminal. And the cool part is that you can easily extend it with many more features. In the last video, we built a very simple SQL agent, but we can barely call that an agent as it's a single-step process. The user sends a message to the AI writes an SQL query, runs the query, and gives back the answer. But today we go further by building an agent that can achieve complex coding tasks that involves multiple steps, multiple files, and code execution. And to do so, we are going to use only Pydantic, the Anthropic SDK, and Rich to beautifully format text in the terminal. The project will have many cool features, including the ability for the agent to connect to Docker, write files and execute them in the isolated container, so you are safe and you don't risk to run weird commands on your own system. Also, it will be able to write tests and make sure the code passes those tests. It will also have the ability to iterate until the task is completed. And finally, it will support streaming, so we get feedback as soon as possible in the terminal. So I hope you're hyped for this tutorial. And we are going to start by presenting you 3 examples of the final product to hype you even more. Let's go. Okay, so we start with the first example. In this example, I run the agent on the left here and the Docker on the right. As you can see, I connect to Docker, so it's the development container that will use the agent to write and execute code. I connect to it so we can see in real time the files created. The first example is about creating a web-based game. So the game will be a ThreeJS game, simple, displaying some shapes that we can control with the keyboard, and it will serve the game on the computer. So the first thing that happens here, as I ask the agent to write a project, it uses a tool to ask me some clarification. So there is a tool that can interact with me to bring more details if the model is not sure about the task. So here it asks me to specify a bit more what's the project. And that's where we specify the ThreeJS query and the game in an HTML file. So as you can see here, it was a bit fast, but it created a file here, the game.html. And now he is checking the Python version, installing Tmux, and running Tmux in the background. So he's running Tmux to run the Python server in the background and not block the main thread. Now we can go to localhost 8888, which is the port mapped from the dev container to the host. And as you can see, we have our game, so we can rotate the cube and push it further and bring in the cube closer. Very cool, but we go a bit further now. We ask to change the color. So we go to, we ask for the red color. As you can see, the model here changed the file, and we get to reload our project, and the cube is red. Well done. Well done, AI. Now, to spice things up a bit, we ask to create a rotating sphere around the cube. So the file is written, and we can now update the page, and we'll get a rotating blue sphere. Very nice. Now we asked to shut down, so shut down the server. As you can see, the model runs a command to kill the Tmux session, and the project is stopped. Okay, so we'll go a bit faster on the second example. Same setup, left the agent, right the Docker container, so we can see the files. And in this one, we'll ask the model to create a simple FastAPI server with an SQLite database. So it has persistence, and to create some CRUD endpoints, so we can add objects, remove them, update them. So as you can see, the model starts working, it creates files, download stuff, so FastAPI and so on. So first it creates the database.py with SQL Alchemy. the models, the pydantic schemas. Finally, we get the FastAPI. It installs a few libraries and starts the Tmux session. So now the server starts, and on localhost we get access to the FastAPI server. So I go to the doc here and I run a few requests to illustrate. So here, as you can see, I create a user and it works. So we get the 200 code and the data. Then we can list the user. So we get the list of users. We can do a bunch of other operations like update, delete, and it works. So the model is able to write multiple files in the same project, even create databases and maintain state. Last example for the data scientist out there. So again, we start the agent, same configuration, but this time we'll ask to download the dataset, create a train test split, and train a data science model. So let's say a machine learning model, with the train test split to validate the accuracy of the model. So as you can see, it wrote the code. It installs a few packages. And then it runs. As you can see here, we get the output, so the accuracy, precision, recall. Very nice. The cool thing is the model will ask for a follow-up question, so how can we improve it? And we propose to add cross-validation. So the model goes, writes the cross-validation stuff, and it works. And as you can see on the right now, I can connect to the Docker container and run myself the code that the model written and executed, and I get the same output, so it works. We have all the files. Okay, so let's dive into the code. I hope the demonstration gives you the motivation to try to build your own agentic loop instead of just relying on agent SDKs. You can use them later, but building one yourself is pretty useful to really understand what happens. So let's take a quick look at the files first. We have the agent file, which defines the main agent. It's the first file we'll investigate. We have the tools file that define the tools the agent will be able to use. The clients, very simple. It has only the Docker client and the Anthropic client defined. And finally, the simple UI, which is just running the agent, but displaying the output beautifully in the terminal. So let's start with the agent. Here is the agent class, and it has a few attributes that we can inspect. So first, the system prompt. The system prompt is a prompt that you write to guide the behavior of the agent. This is a really important prompt, and it will have some impacts on the quality of the outputs you'll have. Then we have the model. I use the Anthropic SDK, but Anthropic has many models available. So here you can specify with a string the model you want to use for this agent. Then we have a list of tools. We'll inspect the tools just after. The list of messages. So this is the history for the agent. So it will have the list of first the user message and all the tool calls that the agent is running. And finally, we'll have the available tools. So it's the same, almost the same as tools, but formatted in a way that the model can understand. Then we have three main methods. We have the post init. It's just a function that initializes the tools from the available tools from the tool. So it formats, as you can see, in a dict every and each tool we have in the tools list. Then we have the add user message. Really simple, takes a string and appends a message using the types from Anthropic. So it's a role user and the content is the message. Then we continue and we have the most important function of the entire project. It's the agentic loop. So the job of the agentic loop is the following. Given our current history, generate the next completion, and then, if the model decides to make a text completion, we are done, basically, and we return the text as the output of the agentic loop. If the agent asks for a tool call, then we run the call, give the result back to the model, and run the model again. So we call back the agentic loop recursively again. Now, to make things a bit clearer, let's dive into a simple illustration. Okay, so here is how the agentic loop works. We have our system message and a user query. So create a simple web game with ThreeJS, as in our first example. Then we start the agentic loop. The model chooses to make a tool call with the tool called createFile, the path game.html, and the content of the file. The next step is we run the tool and give back the result to the model. Then the model has a choice. It can choose either to make another tool call or to finish the loop. Here it chooses to make another tool call. So serve, the tool for serving a file, and the path to the file, so game.html and the port. Then we run the tool, answer that it's successfully served, and finally the assistant writes a text message, so it chooses to break out of the loop, and we can display this message as the output of the agentic loop. So I created a web game, served it. You can check it on localhost.8888. The part in green is the agentic loop. This is the part that can loop multiple steps, and this part we do not really control. It's the model that decides when it's done. So every time the model chooses to use a tool, it keeps the loop running. And at the moment it starts to make a text completion, we break out of the loop and show the output to the user. You can also see it as a simple flow process. So we start with a history, which has only a user message. First, we get a completion from the model. It chooses to make a tool call. So we get the tool results, append the results to the history, and call the loop again. So we get two new messages into the history, the tool use and the tool result. Then we restart the loop. So we get another completion. The model asks again for a tool use. So we get two new messages in the history, the tool use, and the tool result. And finally, the model decides to make a text completion. So at that moment, we break out of the loop and we display the final assistant message to the user. Okay, so now let's go back to the code so we can see the concrete implementation of that agentic loop. So if we look at the signature of the function, we see that it returns an asynchronous generator of agent event. The agent event, I created them here. It's either an event text, an event input JSON, an event tool use, or an event tool result. The event text is a delta of text from the streaming. An event input JSON is a delta of inputs for a tool use. Then we have the tool use event. The tool use event is an event that happens just before we make the tool call, when the entire streaming for the tool is done. And finally, we have the event tool result, which is an event that we emit when the tool is done and we have the result. So our generator here for the agentic loop is streaming events of the agent event type. So then it will be easier to build a UI on top of it, the terminal UI, by just getting those events and printing beautifully in the terminal. So here's how it works. We start with tenacity. So it's just retrying multiple times if we get errors from Anthropic, because sometimes the API can be too busy. So we don't want just to fail. We try 3 times and wait a fixed time of 3 seconds. So the first step is to create a message completion. To do so, we use the Anthropic SDK. We specify the max token to 8,000. The messages, we use our history, we use our model. The tools, we use the tools available, so the model is able to pick a tool. And finally, we have the system prompt. Then, using the stream from Anthropic, we iterate on the different event type. So if we get an event of type text, we stream an agent event of type text. If we have an input JSON, I emit with the yield keyword the event input JSON, and we keep doing so for the entire stream. At the end of the stream, we get the accumulated message, which is the sum of all the delta that we received from the Anthropic SDK. Finally, we append this message to our history. So it's an assistant message. Now, we check the content of the accumulated message. If it contains a tool use, we find the tool by looking in all the tools we have at our disposal and matching on the name, and we call the tool to get the output. But before we emit an event, so a tool use event, so that our UI that will build later can display something in the terminal when a tool is called. Then we have our result here. And finally, we yield the output of the tool also, so we can display it in the terminal. Now, when you have a tool use in Anthropic, the way to provide the answer to the model is to append a new message of type user with the content tool result block param with the tool result type. Here we put the content ID, which is the ID of the tool call, and the result, which is the content of the output of our tool call. Finally, we check if the accumulated message stop reason is because of a tool use. This tells us that the message asked us to make a tool call, and if it's the case, we recursively call back again the agentic loop. So if you remember, it's the part where the loop can loop for an undetermined number of steps, because here the model can call many tools one after the other. If it's not the case, we go out of the function, and so we just return the latest message. Now let's see how we define the tools, which is a really important part of that project, but very simple as you will see. So to define the tools, I leverage the Pydantic library because it's really easy to build an object that is typed checked at runtime, but also can generate its own JSON schema. And the JSON schema will be super useful to describe the tool to Anthropic so it knows how to invoke it. So I define the tool as the following. A tool is a base model with a function call that is asynchronous. So then every tool can be called after being instantiated. The first tool we create is a tool to run a command in a development container. So you can see here I verbose in the doc string because this doc string will be in the description of the tool. It will be automatically done in the JSON schema by Pydantic, which is really cool. So this tool takes just a command as a string, and it has a run function here. So this function tries to find the Docker container, Python dev. Then it executes the command using bash.c and the command here. And finally, if we get an output, we just return this output as a string. Otherwise, we format it with the error and the content of the error. Finally, the call here calls this function into an async IO thread. So we transform this synchronous code into an asynchronous code. Then we have a specific tool to upsert a file. By upserting a file, I mean either creating a file or replacing the file if it already exists. This function, this tool, takes a file path as input and a content. And here we have to do something a bit special. We use a socket to stream the std in to the container, because sometimes when you have a file with special characters, if you just pass it to bash, it will fail. So just a simple trick, but it works pretty well, and it will just give as output file written successfully. Again, as we interact with synchronous code here, the Docker SDK, I wrap the call into an async IO2 thread call to make it asynchronous. Now, we have a tool to display an artifact. I don't use it anymore because it can be used, we can use other tools to use it, for instance, just running a command in the terminal. But here it just displays something. So the model can ask to display this artifact and we can display it in a specific way. Then we have a function here. It's not a tool, but it's to start the Docker container. So relatively simple here. We just check if it exists. If the Docker container exists, we kill it, destroy it, and run it again to avoid having some weird state in the container. And that's it. And finally, we have a last tool, which is really important. It's the tool to interact with the user. So we want the model to be able to interact with us without breaking out of the agentic loop. To do so, it can use a tool. So the tool will just ask us a question that we can answer, and it will get this answer as the tool result. So here I use a specific function so we can give a prompter, which is a parameter. So the prompter is just a callable that takes a string and returns another string. So here we have the query. So the query is what we will display in the prompter. So for instance, the model asks a question, the questions will be the query. And finally, there is a display. So if the model wants to display a specific file along with the query, it can use the display. And we'll just format it nicely in the terminal. Finally, we call this prompter, get the output, and give back the answer to the model. Finally, let's put everything together in the simple UI.py file. So in this file, we'll just create our agents, create our tools, and write the output beautifully to the terminal. So here, as you remember, to create the interaction tool with user, we need to specify a function that returns the output of the user. To do so, we use the prompt from rich with some formatting, so we can display with some format the query. We get the answer from the terminal from the user, and we return this answer. So this will be used as a tool for the tool interact user. Then we have an array of tools. So our agent has only 3 tools: run command in a dev container, upsert a file, and a tool to interact with the user. Then in the main, we create our agent. We use 3.5 Sonnet. We pass the tools, and we have our system prompt. So this is relatively important here. I invite you to look into the code, as I will share share with you the GitHub link, because it's a bit long, but it's a way to really specify what I want from the model, to write good code, try to test the code, and so on. Finally, we start the dev container using our function to create the Docker container, and we enter into a loop. In this loop, we query the user. So we use a simple input from Python to get the initial query from the user. And after that, we call the agent.run. Agent.run, if you remember, just calls the agentic loop. Now we can match on the events that are streamed from that loop. So if you remember, we defined 4 agent events. First, if the event is a text event, I just print it with flush true, so we can append the text in the terminal. We have the event tool use. So if the model starts to use a tool, we want to format the output beautifully. So if it's a tool run command in a dev container, we create a panel and we put the title here with the name of the tool, and finally the content that contains the command that the model initiated. Then we have the tool to upsert a file. So same thing, we specify the file path and the content. And finally, we have a last case. If it's a tool interact with user, we also display the query and the display. So the display, if you remember, is an additional file that you want to display with a query to get feedback from the user. Finally, we have the event tool result. So every time the tool is called and we get back a result, we create a panel with the content of the tool call. And that's it. Then we call the main function and we get our agent. So going back to our example, if we call uv-run simple.ui, you will see everything. So here we have the Docker container starting, and we can say, hi, write me a project, please. Now you see the user wrote a message, and we start to go into the agentic loop. At that moment, the tool code is well formatted. We have the tool called tool interact with user. We have the query. So here, could you please provide more details about the project you'd like to create, and a few additional details. And then we have the display. So here the display is exactly the same, but it's in some cases, it can be an additional file. So let's say the model shows you a file and asks you, what do you want me to do with that file? Or is this change good for you? And then you can put your answer. So write a simple function to add two numbers and test it. As you can see, we get the tool result formatted here in green in the panel, and we have the follow-up. So here, the model gives some text and calls another tool call. So this time, it wants to run a command in the container. So it creates a folder called calculators test, and then it writes a file into the test, so testcalculator.py. Here, if we go there, we can see that we have in calculator, we have all the files. So ls cat calculator.py and cat calculator tests.calculator.py. Now, if we take a look, we see that the model runs the test here by using the tool run command in dev container and the test pass. So then it goes back to us and asks us for the follow-up. So what we want to do next. All good, thanks. And that's it, we are done. So now you can keep going, you can ask the model to change stuff, as we did in the first three example. You can really play with that. And I would really encourage you to try to add a few features. So for instance, you can add your own tools. That could be really interesting. You can also, I think one of the cool thing to do is to add a browser use tool, so the model can browse the web. But there are many things you can do. You can take a look at Manus and try to implement some of the features it's able to achieve. So yeah, that's it. I hope you like this tutorial. I really invite you to try to build your own agentic loop. To me, it was really helpful to really deep dive and get a good understanding of what's happening when you use agent. And even if you use your I don't know, OpenAI Agent SDK, CrudAI, or other thing after, to be easier for you to have an idea of the typical problem that can arise or how it works in the background. So thank you. I hope you liked the video. I will prepare new tutorials regarding agents, maybe improving this one or showing you more complex use cases. And in the meantime, have fun and see you in the next one.